Hi everyone. We are doing the GC analysis of our simple and fractional distillation. So probably you guys have heard about GC in your lecture and stuff. So GC is like a gas chromatography. So we are using the techniques of chromatography, but using our gas for here. I think we are using compressed gas as our mobile phase. So what actually happens in the GC is you have like a stationary phase and there is like a mobile phase that kind of helps the components of our mixture to kind of move. So probably it's like you will learn much more about the techniques, principles, and everything in your lecture. But for now, kind of just like the basic overview of our instruments we got here. So so this is the GC we got is the Simaju Gas Chromatography 2014. So the cool thing about this stuff is here, as you guys can see, there's like a screen for the GC and all the control buttons and everything in here, and also you can control the GC from your computer as well. So the first step, what we gotta do, let me try to zoom in into the screen, is let's see this. Okay. So the first thing is I'll just exit out of it. So there's like a file or the software called Lab Solutions. So you open it. So basically, after you open it, you will have the screen like this. Actually, screen like this appear in here. And what you do is usually there's like a method file somewhere in the folder on the computer. So what the method file is exactly about is it has like all the stuff you need to set up for the polymer, like our chromatography here. And after you open it, then you download it. So basically by downloading, what you are doing is from this software, you are actually putting all the parameters and everything in the gas chromatography, like a chromatogram, like GC. So basically, it's asking the GC to run this following fixed parameters. So what you can also do is, so there's the SPL. So this is the injector, like temperature and everything in it. And then there is a column. So the column is where all the separation of your components actually happen. So as you can see, this is the parameters that we have chosen for our for this experiment. So it is like 35 degrees Celsius and hold time for a minute, and then so the rate of 20, what basically means is like it increases the temperature of the volume by 20 degrees Celsius, and when it's at 125 degrees, it holds it for like 1 minute. So that's how it kind of like works. And like how we figure out these parameters is basically like by running like bunch of stuff and looking at like which method actually worked the best for the separation. So you can even like change it if you want. Basically increase it or decrease it, and also like increase or decrease. So you can change the parameters if you want, but you need to figure out what works the best for the separation you have. So for our experiment, we have our distillate for the simple and fractional, basically between the cyclohexane and toluene. What we gotta do first is run the reference point. So by that, what I mean is that we're gonna run the sample, so this is the cyclohexane. So this is the pure cyclohexane that we got from the stockroom. So basically, it's like 100% pure, or if not, then 95 around. So I'm gonna get a bit of the sample and run the GC and get a reference spectrum for it on the graph. So we use the like a microsyringe for for GC. Since we are doing cyclohexane first, let me get a chem light. So what I'm trying to do here is I'm gonna get this syringe and just like wash it 3 times. So make sure like the syringe over here has only stuff that we want. So 1, 2. So you don't want like a lot of your sample or the mixture components that you want to put in the GC, because if you have like a more like components, then you get like a peak that's kind of weird, and also it's like hard to integrate and everything in it. So this is our 10 microliter syringe, and it goes from 0, 1, 2, 3, 4, 5, 6 up to 10. So we gonna only take 0.2 microliters of our stuff in it. So what I like to do is basically just do this. Too much. Yeah, looks like 0.2 microliter to me. So here is our GC. But this is the injector. What you gotta do is you press the, so there's like a septum in it, and so at the same time, I'm gonna start like single run. And inject it in there. So it just gives you kind of like some sort of error or something, but just like press OK and it works. So here is your column, and so the column temperature, primary pressure, the flow of your compressed air or mobile phase, and SFID1 temperature, so that's like the injector temperature. So it basically is running, and you probably will expect a peak very soon. So what's exactly happening in here is we are using the temperature or like a maybe plasma or stuff in it, like a flame, to vaporize your liquid components. And so what happens is like there's the column, like the column probably we are using is copper wire or something, but like the stationary phase and there is the mobile phase. So what that does is like if you have like 2 different components with 2 different polarities, so that the separation happens and one comes out before the other. So kind of like that's the basic principle. So we are waiting for the peak to occur in here, and so as we can see the line is moving, so that basically means like GC is actually working. So I'll pause for a bit, and when we have the graph, I will resume and show it to you guys. Okay, so we have our peak here for cyclohexane, and it's been around like 2.5 minutes, so I kind of feel like this is the only peak we're getting so far. And so as you guys can see, there's like a small like there's basically kind of like 2 peaks out there. So there are like a lot of reasoning behind like why the peak kind of looks like this. So one of the possibilities, it can be like the cyclohexane I got was not pure enough, and there was something in it. So that's why we're kind of seeing 2 peaks. But like the other stuff can also be when I did the injection, only like some part got evaporated first, and the rest got evaporated like later. That's why we kind of see like that dent in our peak. But it kind of looks fine to me. So what I'm gonna do is I'm gonna stop it. Yes. And then so here's the option called data analysis. So I'm just gonna click that. And it will open like a different software. This one was from the T, so okay. So this is what I kind of wanted, right? So the table right here, it gives you like all the peaks that are kind of shown, but the peak with like 2014, 2064, they're like very small. So one thing what you can do to get rid of that is you can edit, and then so if you just increase the like minimum area height, like I would just have 20, and then view. So what it does is like it basically got rid of those all the small peaks that we got. So I'm just gonna print this. So click the data report right there, and then it will take you to the analysis spectrum. So it looks like there's some problem out here. Okay, well, I need to figure out a way. Okay, so data analysis. Okay, so now we have our peak right here. So I'll just print it and I'll send it to you guys probably through Canvas or something. So we did our reference for the cyclohexane, so now we gotta do the same thing for toluene. I don't want to show you guys like all the process of injecting and everything because it's the same thing, but I'll show you just like what the spectrum looks like. So the first thing, clean it 3 times, and then you have this software right here, and then you start a single run, name it and everything, you inject it, press start, and it does the rest. So I'll show you guys after I have the spectrum ready. I just injected the toluene reference sample in GC. So since the time is moving, that basically kind of means the GC is working. And if you look at the temperature, it's right now 25.2 degrees Celsius column temperature. So the first, it gotta go to 35 and then to 25 since we set it up that way. It's gonna take a few minutes for us to get the peak, but I'll show it to you guys soon. It's been around 5 minutes, and we have seen the peaks. Seen a peak right here at around 2.5 or 2.3 minutes. I'm gonna stop GC and do the data analysis. So here, data analysis. And so this one is perfect because we got only one peak. So that is what was supposed to happen, right? So for one component, you were supposed to get one peak. So after it ended the collection, I basically just click the data analysis. of weird. This is not a big we wanted, so something probably got messed up. I feel like the first reference and this reference, they kind of combine and just gave me the printout, which I don't think I want that. This is not something I wanted. I'm gonna do it again. Data analysis. Hopefully we will get a peak this time. Okay, so what we're gonna do is we're gonna do the same thing. We're gonna just increase the number of gyro and our minimum height. So that will give us kind of the rid of unnecessary peaks that we have. And as probably you guys can see here, there's like this small peak at around 1.25. And also like for the cyclohexane reference, you had a peak at around 1.25, right? So that kind of hints us that the syringe was not completely, like it did not completely get rid of the cyclohexane, and there was some cyclohexane in it when we used the same syringe from the cyclohexane reference to the toluene reference. But so this is our big picture. What we're gonna do now is data report. Print out. So now that we have collected all our reference CC spectrum, we're gonna run our simple and fractional distillate and then compare it with what we have obtained so far. So let me go grab all the distillates. So here I have my simple distillate and fractional distillate that we're going to use for GC. So the first step, as I probably mentioned it a couple of times already, you have your syringe and wash it 3 times. So 1, 2, 3. So we want around 0.2 microliters because that works pretty well. So that's the first line you see right here. Got my simple distillate, and here at the GC, this is our injector, right? So what I'm trying to do is get the syringe all the way in there. So if you can read it, it says click or push start just after the injection. So I'm gonna inject it and press at the same time. So this is all good. So I can take the syringe out. This is just like a warning, or like something it gives all the time, but I don't know what it is. So it's running. We're gonna wait for the peaks to appear, and then I'll show you guys so you don't have to like wait all like 5 to 10 minutes and see the peaks moving. Around 4.5 minutes, and I can already see the peaks out here. So we have 2 peaks. The one at around like 1.25 to 1.5 minutes, and the other one around 2.6 to 3 minutes. So this kind of like definitely hints us that we got 2 peaks, 2 components in there. Just kind of like try to analyze why it might have been the way it is. So I'm gonna do the data analysis and stop this data operation right now. This is the peak, right? Oh, sorry, printing. Well, I did not try to, but so new spectrum. What I'm gonna do is edit and increase the minimum area or height, and try to get rid of the. Okay, so now we have two ticks right there. So if your spectrum like is not complete there, what I kind of did the last time was you go in there, you click, and then setting scale, use data range, and then did this, yep, and then print it. So this is our simple distillate, and we're gonna do our fractional distillate in a second. I have my fractional distillate right here. I'm gonna wash the syringe with fractional distillate 3 times. Show it to you guys because this is our last run. So you guys kind of missed it before. Might be a nice review. So we only need 0.2 microliters. So that's the first line. Okay. And here's our GC instrument. So right in the middle, there is a septa, and your syringe will go all the way in. So I gotta press start right after I press the syringe. So what I'm gonna do is here, 1. So I inject it, so I can now take it out. Just kind of put it out here. Just ignore the warning report because I don't know what it is. So we're gonna wait a few minutes for our fractional distillate GC spectrum. Been around 4 minutes, and I can always see 2 peaks. So there is like one large peak and one small peak. I'm assuming this one is for cyclohexane and the other one's for toluene. And since this is a fractional distillation, it is supposed to be a bit more effective compared to the simple distillate. And if you compare the 2 spectrum, you'll find why it is, or like you can find like a supporting answer for that. I'm not going to analyze and explain why fractional distillation is better, just comparing the spectrum to the other, but it's up, like it's for you, it's like something for you to do. So what I'm going to do is I'm going to stop the data accuracy, yes, and then do the data analysis. Also, after you use the syringe, what you gotta do is like get a bit of acetone or isopropyl alcohol and just wash it 3 or 4 times and just leave it out there. Because if you're using it to the syringe to like kind of inject the organic compounds and stuff, sometimes like if you don't wash it properly, it just might like get stuck in there, and the syringe might like kind of not work. So trying to get rid of the peaks. So there. Go to setting scale, and then here it is, print it. So this would be everything for our GC collection for our reference and simple and fractional distillate. So using all the 4 spectrums that we have, including reference and the fractional and simple distillate, you might be able to get all the answers you need. So that's everything. I hope you guys are having a good week.